In modern architectural software, dropping a custom carpet into a space takes about one click. You drag an image file, drop it onto the floor plan, and instantly, a wireframe room becomes a photorealistic interior. But computer monitors are essentially optical illusions. They display perfectly flat pixels that never have to answer to gravity, friction, or the laws of physics. When you look at an RGB pixel on a screen, you are seeing projected light. When you look at physical yarn, you are looking at a three-dimensional structure that absorbs light, casts shadows, and changes color depending on which way the fibers are pointing. If a design doesn't account for that reality, things break down quickly. A thick, luxurious pile might look incredible in a rendering of a busy hotel lobby, but in the real world, that thick pile will completely paralyze the wheels on heavy luggage trolleys. Moving a bespoke carpet from a render to reality is a technical translation. Every line, material, and construction method must be re-engineered to survive the physics of the project site. Before looking at a single design layout, we have to ask a blunt question. Where is this carpet actually going to live? A floor covering has to survive relentless physical stress. It will face thousands of footsteps a day, aggressive industrial cleaning cycles, and the constant concentrated grinding of wheeled furniture. A successful manufacturing run solves all of these environmental problems up front, long before a designer draws the first line of the pattern. Once the environment is understood, the architect's CAD file has to be broken down and converted into a highly specific technical layout that a weaver can physically follow, dissolve into visual noise. The artwork must be carefully thickened and simplified. The entire pattern also needs to be mapped against the footprints of tables and sofas. If a massive abstract design is perfectly centered in the room, but the most important visual element disappears completely underneath a heavy boardroom table, the translation has failed. Color selection then steps completely out of the digital space. Because physical texture alters how dark or light a shade appears, designers must verify their colors using actual yarn swatches under the project's specific lighting conditions. The choice of that yarn dictates how the rug performs. Wool provides a resilient, highly structured utility that bounces back from heavy use, while silk offers extreme detail and a light-reflecting sheen that works best in low-traffic luxury spaces. The objective of all this drafting and sampling is to protect the original vision. We have to guarantee the design actually survives the jump from pixels to physical fiber. With the materials chosen, the project moves to the loom, relying on three distinct mechanical construction methods. In hand-knotted construction, seen up close here, every single piece of yarn is tied by hand around a foundation thread. This creates a dense, labor-intensive matrix capable of supreme detail and longevity. Hand-tufted rugs take a different approach. Yarn is punched directly through a prepared backing. This drastically reduces production time and allows craftsmen to easily carve different pile heights and deep textures into the surface. Finally, flatweave construction weaves the threads together without any raised pile at all. It yields a rigid, low-profile surface, perfect for sharp geometries and ensuring doors can easily clear the floor. This image shows what the industry calls a strike-off. Before committing to a massive manufacturing run, the factory produces a small, fully realized physical prototype of the complex design. This small prototype allows the design team to catch errors in color or texture before the final carpet ever enters full-scale production. It is the final checkpoint before committing the project's manufacturing budget. Once that 2-foot sample is approved, it has to be scaled up to architectural proportions. Expanding a pattern across a massive floor space without stretching or distorting the geometry requires precise structural engineering at the loom. And when the weaving is finally done, the rug is nowhere near ready. The raw textile enters an exhaustive finishing stage, where it is chemically washed, its pile is meticulously leveled, and the edges are tightly bound. This includes surface carving. To create physical depth, structural lines are literally scissored straight into the dense wool pile by hand. The rug is only complete once these manual refinements, the leveling, washing, and carving, transform the raw woven surface into the intended architectural texture. The process starts with a fragile, weightless digital file, and it ends with a heavy, durable installation anchored to the floor. This is the true advantage of custom manufacturing. Instead of forcing a carefully designed room to accommodate the fixed dimensions of a standard catalog rug, the carpet is engineered specifically to adapt to the architecture. The most effective spaces occur when the architect's layout, the designer's color theory, and the craftsman's loom are all speaking one unified physical language.